All right, I'm going to finish up the systems of equations by graphing lesson. But I'm going to recap, first of all, what we talked about on Friday. So if you take a look at this, I don't want to capture anything. Let's get rid of that. If you take a look at this, it says, what is a system of equations? A system of equations is two or more equations that work together to produce one solution. However, we'll only be dealing with two, but they have to work together, main thing, to produce one solution. So let's talk about what a solution is. So what is a solution to a system of equations? A solution to a system of equations has to be an ordered pair. Main thing is it's an ordered pair. I'm going to highlight that. Let me get it off corner. It's an ordered pair. And what does this ordered pair do? It makes the left side of an equation equal to the right side of it. Not just in one equation, but in both equations, okay? So you'll pick some x and y, which is some ordered pair. You can replace x and y in both, and the left side will equal to the right side in both. All right, so we talked about the types of solutions you could possibly get. If the two lines intersect, they cross each other. At some point, you get that point is your solution. That point is your solution, a point of intersection. And you have one solution, but you must make sure if you have one solution that you name it. You name it by naming the x coordinate and then the y coordinate. So we'll know what it is. You got to name it. All right, sometimes the lines never intersect. So if the lines never intersect, in other words, they run parallel to each other, there's no solution. You can also use that symbol. Key thing, you'll see this later in another example. Parallel lines will end up with the same slope or the same rate of change. Okay. Sometimes the lines are identical. The lines are identical. That means they're the same line and they're touching everywhere. So if they're touching everywhere, it's an infinite amount of solutions. They're intersecting everywhere, guys. We also talked about if you're going to solve by graphing, you want to make sure your equation's in y equals mx plus b form. All that means is that y must be by itself. And once it is, you can easily identify the slope because it's always attached to x. The slope in x or the unit rate in x or rate of change in x, they're best friends, whatever you want to call it. Rate of change, slope, unit rate, same thing. All right, and the y-intercept is not attached to x. It's that one that's by itself. All right, we graphed number 1 on Friday. We graphed and we found the point of intersection to be 3, -5, an x of 3 and a y of -5. So this is the ordered pair that makes both sides equal in both equations. Okay, let's take a look at number 2. Some groups did number 2, some groups didn't. I don't know which ones did and which ones did. So I'm just going to start over and do number 2, making sure I got everybody, regardless of what class you're in. All right, so I'm going to take a look at this first graph here, that first equation. What is attached to x? 1/2. So your slope is 1/2. You will have a rise of 1 and a run of 2. And your y-intercept is not attached, but keep in mind y must be by itself, and it is. Your y-intercept is 9. So I'm going to begin at 9, and I'll show you here. Begin at 9 on the y-axis. So you're going to go up. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You're going to always start on this line. If you don't start on that y-axis, that number line right there, then you're wrong. So I'm going to start right here at 9. And then my slope tells me to rise +1. So I'm going to go up 1. And because my run is positive, I'm going to go to the right. Up 1 to the right, 2. However, I don't have any more room. So I'm going to reverse this. I'm going to go back to my point of my y-intercept. And instead of going up 1 and right 2, I'm going to go down 1 and left 2. And I'm going to continue that. Down 1, left 2. Down 1, left 2. Down 1, left 2. Now I can connect the points. There's my line. Guess I'll do the other one in red. All right, this has an imaginary -1. So the slope is -1. It has a rise, but no run. So I put a 1 for the run. My y-intercept is 6. So I'm going to begin on the y-axis at 6. 1, 2, 3, 4, 5, and 6. And then according to the slope, because it's negative, instead of going up, I'm going to go down 1. And because the run is positive, I'm going to go right. So down 1, right 1. But as you can tell, if I go down 1 and right 1, I'm going away from my line, that black line. I don't want to go away from my black line, so I'm going to reverse the slope. So instead of down and right, I'm going to go up and left. So go back to your point of intersection here, your y-intercept, which is here. You're going to go up 1, left 1, up 1, left 1. And I can tell where they intersect already. I'm just going to connect the dots. And I'm clearly able to tell that they intersect right here. So I got to figure out what x is that. So that's 0 in the middle. 0 in the middle. So this is an x of -2. And the y is up 1, 2, 3, 4, 5, 6, 7, and 8. So the point that makes the left side of the equation equal to the right in both equations is -2, 8. Okay, let's take a look at number 3. The problem on 3 is that y isn't by itself in either one of those. I'm going to have to do a little work on these. So you get y by itself in each one. I'll do this one here. I'm going to put an imaginary 1 in front of that. All right, so the whole goal is to get this by itself. So you just ask yourself on the top one, what's keeping you from having your y by itself? Well, that would be the whole -3x. So I'm going to make a 0 pair with 3x. Do not line these up underneath each other. Don't stack them like that because they're not ordered pairs. They're not like terms. Okay, these are going to cancel, and I'm left with y equals to 8 plus 3x. The slope is 3, or 3/1. So it has a rise and a run. And my y-intercept is 8. That's for the top equation. For the second equation, I need to get y by itself. So I'm going to add 1x to both sides to make a 0 pair. Again, I am not stacking them right here like that. 1x with -2 because they're not like terms. So those cancel. I get y equals to -2 plus 1x. The slope is the number attached to x, which is 1. It has a rise of 1, but no run. So I put an imaginary or understood 1. And my y-intercept is -2. All right, I'm going to start off by graphing the one at the top, this one. I'm going to begin at 8 on the y-axis. That's 8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. And this thing says I need to go up 3 and to the right 1. I don't have enough room to go up 3 and to the right. Can't go up 3. I'm going to run off the graph. So I'm going to reverse it. So instead of going up and right, I'm going to do the opposite of up, which is down 3, and the opposite of right, which is left. So let's go down 3 and left 1. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. And I will continue that until I run out of room. Okay, let's make our line. Okay, let's go ahead and go ahead with this one. So let's take a look at that one. This line has a slope of 1 over 1, but a y-intercept of -2. So I'm going to begin here at the y-intercept of -2. And because it's a positive, I go up. My rise is positive, I go up. If my run is positive, I go right. Up 1, right 1. Up 1, right 1. But as you can tell, my red line is not going toward my black line. So let's reverse this. Instead of up, let's go down. Instead of right, let's go left. So go back to your beginning, which is a beginning of -2 on the y-axis. Go down 1 and left 1. Now I'm going toward the black line. So that's the direction I want to go in. And I can clearly see where they intersect. All right, guys, you should be able to see that the point of intersection is right here. Let me get it out of shapes. Okay, it's right there. No, it's not that one. Sorry, it's this one. That's where they intersect. Okay, so what point is that? That's 0. That has an x of -1, -2, -3, -4, and -5. It has an x of -5. And what's the y? Let's see, -1, 2, 3, 4, 5, 6, -7. -1, 2, 3, 4, 5, and -7. 1, 2, 3, 4, 5, 6, and 7. There we go. So that is the ordered pair that makes the right side equal to the left side of the equation in both equations. So that is your solution. And I'm going to take a moment just to show you again what I mean when I say left side equal to the right side. And you don't have to write this down, but definitely watch me, okay? This isn't wanting to erase, so hold on, guys. Bear with me. Okay, so I'm going to take the solution. -5, -7. That was an x, and this one was a y. So I'm going to take the equations, and I'm just going to plug in. So I'll do that one first. So I'm going to change my x value to -8. And then I'll change the y value to -7 in each one of these. So that's going to be -3 times -5 plus -7. And it should equal to 8. Well, negative times a negative is a positive. So it gives me positive 15 plus -7. Does it equal 8? Well, that's to the right and that's to the left. You subtract according to SADS. And it is more to the right, so it is positive 8. So that checks out. Okay, let me erase this bottom one. And then we'll check it to make sure we have the right solution. Now, I'm not asking you to check each one of them. I'm just doing this so I can refresh you on what we talked about on Friday when I said the left side of the equation has to be equal to the right side if you find a solution in both equations, not just in one of them. Put the -1 in front of that x. I'm going to change x to -5. I'm going to change y to -7 and see if I get -2. Well, again here, a negative times a negative is a positive. And if I use SATs, I'm going to have to subtract because that's right and left. And it's definitely more to the left, so it is -2. So -5, -7 does check off as an ordered pair for both because it makes the left side of the equation equal to the right side of the equation in both of those equations. All right, let's take a look at number 4. All right, I want to start off with the top one. I got to do a little work. I'm going to put an imaginary 1 in front of the x. And I'm going to show you what I need to get rid of to get y by itself first. I need to get rid of the whole 1x and just the 2 that is attached to y. So to remove the entire 1x, I make a 0 pair. Don't stack these over here because they're not like terms. Bring down 2y equals to 4 minus 1x. Now you want to get rid of 2 because it's attached to the y. We only want y by itself. So when 2 is attached, that means it's multiplying something. They're mashed together. The opposite of multiplication is division. I'm going to divide every term by 2. These 2's will cancel. 4 divided by 2 here is 2. And I'm going to leave this as a fraction because that's my slope. I want a rise and a run, and it is in simplest form. So the slope here is -1/2, and the y-intercept is 2. I'm going to go down and to the right. So if I go on the y-axis and begin at 2, I'm going to go down 1 and right 2. Down 1 and right 2. Or you can reverse it and go up 1 and left 2 from where you started. You started right here. You can go up 1 and left 2. Up 1 and left 2. Up 1 and left 2. And that is my line. Now, if you take a look at this equation, guys, y is already by itself. But it has a slope also of -1/2. And its y-intercept is 2. Well, you should notice something. If you begin at 2 and you go down and to the right, it's exactly the same as that one. Begin at 2, go down and to the right 2, down and to the right 2. Then these lines are the same line. You can go up 1 and to the left 2. They're the same line. They touch everywhere, guys. So one line is on top of the other line. So how many places are they touching? Well, they're touching everywhere because one lies on top of the other one. They are exactly the same line. So we say that there is an infinite amount of solutions. If your two equations end up with the same slope, so this one had a slope of -1/2, that one had a slope of -1/2, and they end up with the same y-intercept, a y-intercept of 2 or y-intercept of 2, they're the same line, guys. So you're always going to end up with infinitely many solutions if they're the same line because they're going to lay down. One's going to lay on top of the other one, okay? Same slope, Same y-intercept. So let's put that down. That's what we should note. These lines have the same slope and same y-intercept. I'm going to abbreviate intercept. So if they have the same slope and same y-intercept, it's infinitely many solutions, okay? All right, I'm going to skip 5 and 6. No, I'm going to skip 5. I'm going to skip 5 and 8. All right, let's take a look at 6. I'm going to put an imaginary 1 there. So I can tell you that the slope is 1 over 1. And my y-intercept is 5. So we're going to go up 1 and right 1. Up 1 for a rise and right 1 for a run. So let's begin at 5. 1, 2, 3, 4, and 5. Let's go up 1 and right 1. Or you could go back to your begin point of 5, your y-intercept. You can go down 1 and left 1. And then I'm just going to connect the dots. There's my line. And then I'm going to work on this other equation, this one. Let's work on this one. We'll work on it right here. All right, 1x minus y equals to 2. Because that y is negative, I'm going to go ahead and put an imaginary 1 there because that's negative 1. If that y had been a positive y, I didn't have to put it. But because it's negative, I definitely want to put it. You always want to put, if you don't see a number with x, you always want to put a 1 because the number with x is your slope. And it has to have a top number and a bottom number. So it has a rise and a run. But definitely for the y's, if there's a negative in front of your y, put that negative 1 for me, okay? All right, I'm going to solve. So the things that are keeping me from having y by itself are the 1x and the negative 1. Well, the 1x is completely free from the y, so I'm going to make a 0 pair with it to get rid of the whole thing. Now I end up with, I'm going to have to shift that. Now I end up with this, which is negative 1y equals to 2 minus 1x. To get rid of the negative 1, when it's mashed together, divide everything by negative 1. These will cancel. So a positive 2 divided by negative 1 is a negative 2. And here a negative divided by a negative is a positive 1. You could have left it as 1 over 1 if you wanted to. So the slope is 1 over 1. And my y-intercept is negative 2. Okay, let's work on that one, guys. So let's begin at negative 2. There we go. And according to the slope, my rise is positive, so I should go up. My run is positive, so I should go to the right. Okay, so let's go up 1 to the right 1. Up 1, right 1. But if you'll notice, these lines aren't going toward each other. So I can reverse it to see if I can get them to go toward each other. I go back to my begin point and go down 1, left 1, down 1, left 1, down 1, left 1. But if you'll notice this, these lines are just not going to touch no matter what you do. These are what we call parallel lines. They're never going to touch each other. They'll never intersect. So since these lines are not intersecting, there is no solution on number 6, okay? Now let's talk about what we see in common between these two in the equation. So let's go back to the equation. So I want you to focus on this equation and the slope and the y-intercept. And then I want you to focus on the bottom equation and the slope and the y-intercept. And let's see what we noticed, okay? All right, so what was the slope in this one? The slope was 1/1. Well, what was the slope in the bottom one, the other equation? It was also 1/1. So I can tell you right now, the slopes are the same. So I'm going to make that little note. Same slope. Okay, well, this one had the same slope. They had the same. And I left off same up here. The lines have the same slope. So I got the same slope, just like that one does. But what's different? Why is this one up here infinitely many? Why is this one infinitely many? But then if you go down, this one is no solution. They got the same slope. Okay. Well, up here, if you notice also, they had the same slope and they had the same y-intercept. So let's look down here. They have the same slope. Let's look at that y-intercept. Here the y-intercept was +5. Here the y-intercept is -2. So the y-intercept was +5, y-intercept is -2. They may have the same slope, but they intersect, or that the intercept for the y-axis is not the same. The intercept for this one is 5. The intercept for that one is -2. So what you want to put is they have the same slope, but we're going to use the word but. A different y-intercept. I'm going to use INT for intercept. So when they have the same slope but a different y-intercept, you will end up with no solution because they never meet. Another word for slope, guys, is unit rate, but you will also see rate of change. Please make sure you write that down. If the rates of change or the slopes are the same but different y-intercept, there's no solution. However, if your slopes are also what we call rates of change, if your slope or rate of change is the same as well as your y-intercept, then it's infinitely many solutions because they're touching everywhere. It's the same line. That's the same line, and these are just parallel lines. Not the same line, okay? They just run side by side. Okay, let's take a look at number 7. You're going to pause the video and you try 7 on your own. Then unpause it to see if you got the same answer as me. All right, this is what you should have gotten. You're going to make sure you get y by itself. So you need to get rid of the 3x. And you also need to get rid of this -5. I don't like that color. Hold on one second. So you're going to get rid of 3x, and then I want a different color so you can see you're getting rid of separate things one at a time. The first thing you're going to get rid of is the 3x. You're simply going to change the sign, make it a 0 pair. Put -3x over here. These are going to cancel. So you end up with bringing this down, -5y, if it'll write, equals to -35 minus 3x. And next, what you'll do is you'll get rid of -5. Because it's mashed together, you're going to divide. Mashed together indicates that it's multiplication. The opposite of multiplication is division. Divide every term by -5. Now you have y. And -35 divided by -5 is +7. And here a negative divided by negative is a positive. But 3/5 is already in simplest form, so leave it like that. So here you have a slope of 3/5. Now, if it were not in simplest form, you would need to simplify it. And you have a y-intercept of 7. So for this top equation, this is what I ended up with for my slope and y-intercept. So I'm going to start at 7. Okay. And this thing says go up 3 and right 5. So up 3, right 5, 1, 2, 3, 4, 5. I don't have enough room to do it again, so I'm going to reverse it. I'm going to go down 1, 2, 3 from the begin point. Down 1, 2, 3, right 1, left 1, 2, 3, 4, and 5. Down 1, 2, 3, left 1, 2, 3, 4, and 5. All right, let's connect the dots. And let's work on the other equation, okay? So I'm going to circle this other equation in blue. And we will work on it down here because we don't have enough room. 2x plus y equals to -6. I don't have to worry about putting the 1 in front of the y. Y is positive. Only put the 1 in front of the y if y is negative, okay? All right, so now the only thing I need to get rid of is this positive 2x. To do that, you're just going to remove the entire 2x by changing the sign, making a 0 pair. These cancel, and now I'm left with y equals to -6 minus 2x. So I can tell you the slope is -2, but it doesn't have a run, so put a 1. I will go down and to the right because it's positive 1 on the bottom, down because it's -2 on the top, and my y-intercept is -6. Okay, I need a different color. It's too light for me. Come on, focus on this. -6, 0, -1, -2, -3, -4, -5, -6 is right here, guys. -6 on the y-axis. And then you want to go down 2 and right, down 2 and right 1, down 2 and right 1. But if you notice, I went away from my line. So instead of going down, let's go up. Instead of going right, let's go left. But you got to go back to B, the y-intercept. So go back here, right here. And you're going to go, instead of down 2 and right 1, let's go up 2 and left 1. Now, as you can tell, I'm going toward my other line. That's what I want. And I can clearly tell where they intersect. So I'm able to tell that the point of intersection, I'm going to do it in red. The point of intersection is right here. So that's an x of 0, -1, -2, -3, -4, negative. That is an x of -5. And what is the y? So that's 0, 1, 2, 3, and 4. So a y of 4 and an x of -5. -5, 4 is my solution. Make sure when you write your order pair, you put your x before your y. Just like you say your ABCs, you don't say YXZ, you say XYZ. So x before y when doing an order pair. I am sorry I'm having to skip the ones that have these things in them. I will quickly show you how to graph that. Just x of -2. What you do is you go to -2 on the x-axis, and you put dots on that whole up and down. This is vertical line. Okay, go to find your x of -2. Here we go, right here. and you just draw a line up and down it. That's all you do. Draw a straight line up and down it. And then you could solve for y on that and see where the two intersect. This line though, I'm gonna go back up here and show you this one. If you wanted to graph this, you go to a y of -7. -1, 2, 3, 4, 5, 6. Here's a y of -7. But instead of drawing a line straight up and down, you draw me a flat line or horizontal line. Make sure you keep your y's at -7 for every order pair you put. Every order pair you put has to have a y of -7. And then you just draw a flat line. And what you would do is go back and you would solve for y on this one, get it in slope-intercept form, graph it, and see where they intersect. Okay, let's take a look at this one. It says the graph of a system of linear equations below is shown in the coordinate plane. So I can tell you, let's see, this one. If I divide each of these by 4, I get y equals to -3/4 x minus 1/4. So I'm looking for a y-intercept of -1/4, which is slightly below 0. So this line has to be 4y equals to 3x minus 1. And this one has to be the line 2y equals to x minus 13. But that's not the concern. Let's look at the question. The concern is, why is the point 5, -4 solution? Okay, so if you look over here, here's your point of intersection. That is an x of 5. It's an x of 5 and a y of -4. Well, why is that a solution? It is a solution because it must be the point that makes the left side equal to the right side of the equation in both equations. So I'm going to check it out and see. I'm going to go ahead and put it satisfies both equations. That's normally what you'll see. It's writing like this, guys, because I'm recording. It satisfies both equations. That just means that's the ordered pair that makes the left side equal to the right in both. So I'm going to show you. In other words, I'm going to prove it. Okay, in both of these, I'm going to change the x to 5. And then in both of these, I'm going to change my y coordinate to -4. So let's take a look. So it's going to be 4 times what is my y? -4 equal to -3 times what is my x? 5 minus 1. Well, -16 is what I get here. And here when I multiply these two, I get -15 minus 1. Well, both of the sides do equal -16. Like if you owe me 15 and you owe me 1, you owe me 16. Or you can say they both go left, so I will add them, okay? 15 negatives and one more negative, 16 negative. Okay, let's take a look at this one. So we're going to end up with 2 times -4 equals to what is x? 5 minus 13. Well, 2 times -4 is -8. And that goes right and that goes left. Those are different directions, different signs. Subtract. And it's more negatives than positives. So it checks out in both of them. So my answer of it satisfies both equations is the y. To y of 5, 4, -4 is a solution. It makes both sides of the equation equal in both equations. All right, DeAndre and Leah are making origami cranes. Their goal is to complete 1,000 cranes by the end of the summer. So this says DeAndre already has 30. So that's why his line touches a wider step right here, because he already has 30. But instead of Y, they put C for cranes. He already has 30 cranes. And then he makes 5 more each day. So his slope or rate of change has to be 5 cranes per day. He's making 5 cranes per day. All right, so now you have his line graph. Now Leah already has, I do hers in black. She already has 10 cranes. So this is Leah's because it's 10 cranes. So she started with, but she's making way more than he is. She's making 15 more each day. So her slope is 15 cranes per day, or rate of change. Slope and rate of change, same thing. Okay, all right now. So we understand the graph. We should. The graph shows how many cranes C, and they put C instead on the y-axis is C. On the x-axis, instead of x-axis, they put D for days. It doesn't matter though. All right, it says the graph shows how many cranes each person is making after D days. All right, what does the graph show to be the solution of the system? So where do they intersect? Okay, they intersect right here. So that is a D of 2, which means 2 days. In 2 days, they both will have how many cranes? Let's see. What does it go to? 40 cranes. So in 2 days, they'll have the same amount of cranes. But after the second day, Leah passes over DeAndre, and you can see that they may have the same thing right here on day 2. But then after day 2, look what happens. Leah's graph goes above DeAndre's graph. So after day 2, she'll always have more than he has. All right, but the point, what is the solution? The solution was 2 days and 40 cranes. What does that mean? Well, it means on the second day, they both have 40 cranes, the same amount of cranes. I'm sorry, this thing is in slow motion. Okay, let's take a look at this one, if I can get it to move. Charlotte and Paloma both walk the same trail at the same rate. The same rate would be the slope. Like so many meters per minute. That's your slope. Okay. All right. Charlotte starts to walk first. So where's Charlotte? Charlotte, if I look at this graph, Charlotte's got a head start. She was already 500 meters ahead of Paloma, which is unfair. Okay. Paloma started off at the start line, and Paloma got to go 500 meters above. Okay, I don't get it, but okay, that's the way it is. All right, the graph shows each girl's distance along the trail for the first 40 minutes of Paloma's hike. Okay, well, obviously Charlotte has to be faster than Paloma because I mean Paloma must be faster because Charlotte got the head start. That's normally what we do for people who are slower. All right. Does Paloma ever catch up with Charlotte? Charlotte got the head start. What's going on with Paloma? Well, the point never crosses, and Paloma's line is never above Charlotte's line. So that is definitely a no. Poor Paloma gave Charlotte a head start and never caught up with her. Okay. Also, these lines are parallel, which means the rates of change are the same. So they're walking the same speed or hiking the same speed. In order for it to be parallel, but you know, not the same line, rate of change will indicate that they are. Let me erase that. I didn't mean to put this. I meant to put they. They walk, or you can use the word, I don't care, hike. It's hiking, but this thing is so slow. It's in slow motion, so when I write, you don't see it. They hike at the same speed. I know that because the lines are parallel. They hike at the same speed, but Charlotte started 500 meters, had a 500-meter head start. I put that. So if you're going the same speed, but somebody was ahead of you already, you'll never catch up with them because you're going the same speed. That's just like if Javon and Ethan are racing, and Javon gives Ethan um, a, a 20 feet head start, but they run at the same pace. That means Javon, you'll never catch up with him because you gave him 20 feet, a 20 feet head start, but y'all run at the same pace. So you never gonna catch him. Same thing is going on right here. This is the why. All right, so for homework, I want you to do this last problem here, A and B. I want you to tell me how many solutions each system has, and you can see this one only intersects at one, but this one doesn't have any intersection. But once you identify what the solution is, please tell me what it means. And we'll check this as a do now on, you know what, let's get this over with. Let's get it over with. 4 friends plan to meet at the top of the Eiffel Tower. Each arrives about the time the tower opens and starts climbing the stairs to the top. The graph shows the number of stairs each has climbed in minutes. Okay, stairs is S, M is minutes. So it's going to be stairs per minute for my slope or rate of change. All right, so what's this point mean? What's each point mean here? So let's look at this first one. That means this point of intersection is 10 after 10 minutes. 10 minutes after it opens. This is 10 minutes after opening. And these count by 100s, 100, 200, 300. 10 minutes after opening, they are both at the 300th stair. Wow. I wouldn't make it. All right, so that's what that means. 10 minutes after opening, they're both at the 300 stair. And this one, well, they are never at the same stair. I was trying to go ahead and stop it because this thing is like in delayed mode when I write something that's lagging. There is no solution. That just means they are never, they never meet at the same stair. And that's it, guys. All right, thanks.